Hi everyone, my name is Xiaofei Zhou. I'm a PhD candidate from the Department of Computer Science at the University of Rochester. Today, I'm presenting OptiDot, an optical interface for children to explore dot product and AI recommendation on behalf of my awesome collaborators. We are a group of researchers from the Department of Computer Science, Optics, and Education at the University of Rochester. OptiDot supports kids to directly manipulate light beams as a tangible way to interact with the values and the output of the dot product between two data vectors. In the video, the researcher is rotating polarized film to control the amount of light in OptiDot in order to interact with the process and the output of the dot product. In this optical and tangible interface, we have two sets of polarized films. Each has 3 pairs of overlaid polarized films. Rotating the overlaid polarized films can control the amount of light passing through. These two sets of polarized films represent two data vectors for a dot product. The light passing through them represents the multiplication operation in the dot product. Then there is a convex lens in OptiDot, which can focus the 3 light beams. This represents the addition operation in the dot product. The focus light dot on the last screen represents the dot product output. The brighter this light dot is, the higher value the dot product generates. By rotating the polarized films in OptiDot, the amount of light can be changed, and the output and the values in dot product can be changed. For example, we can decrease the value of the first data attribute for the second data vector, then the output of the dot product decreased. Then we can change the value of the second data attribute in the second data vector to 0. The output decreased again. Change the value of the third attribute in the first data vector to 0. Now the output is 0.1. By placing a color filter in front of one of the polarized films, we can see how much weight this specific data attribute has on the final output of the dot product. For example, because of the value 0.1 here, the second attribute here doesn't really change the hue of the final light dot, which means a very small weight. But if you place the color filter here with a value 1, it largely changes the output of the dot product. The design of OptiDot uses image schemas related to different types of optical phenomena as embodied metaphors for different AI concepts for children to learn. By a preliminary evaluation with 10 middle school students, we evaluated OptiDot's learning effectiveness. More design implications and iterations needed for OptiDot can be found in our paper. Thank you for watching the presentation. Please feel free to reach out if you have any questions.